Hey everyone, welcome. This is part 1 of chapter E, and this is the first video that you're going to be sitting through, and so hopefully it won't be too painful. This is Dr. Rhonda Kofelt, and in part 1 we're going to talk about categorizing measurements, we're going to identify standard units, and then we're going to finally at the end, we're going to convert temperature between Celsius, Fahrenheit, and Kelvin. So that's going to be the calculation for this. So there's two ways you can look at a measurement or an observation. Okay, one is qualitative and one is quantitative. If it's quantitative, that means that you're counting something or you're measuring something specific. Qualitative observations are descriptive. So if I'm watching something happen in a reaction and it goes from green to blue, then that is change in color. That's a qualitative. But then if I tell you that it took 32 seconds to change color, then that is a measurement. Okay, and so we have to look at something called precision and accuracy in measurements that we're going to talk about a little bit later. And if we count things, that's an exact measurement. So that's like a specific number of things. You can't have a half, okay, when you're doing that. But in measurements, you can estimate some things. So we'll look at that. And then the nature of the measurement, whether it's qualitative or quantitative, usually is going to dictate what kind of statistics you use for it. So all measurements are going to have two parts. You're going to have a dimensional unit part, and you're going to have a numerical value part. And the dimensional is just as important as the numerical number. A lot of people really focus on getting that number calculated, and that's fine, but you've got to also use the dimension because, as you're going to see in our discussion for Unit 1, that if you have one definition of a unit and someone else has another definition of a unit, it can really cause some issues. So let's make sure that we are writing our units as well as our numbers when we're giving an answer to a problem. So the standard units of measure that we use in chemistry are length, which is the meter, mass is kilogram, time is seconds, temperature is Kelvin, and amount is the mole. And we're going to learn all about the mole in some subsequent chapters. We also use metric prefixes in chemistry. Primarily, you're going to see these used. Mostly, you're going to use kilo for something that's going to be a bigger amount. And then you're going to see milli, which is a thousandth. And then in between that, you have a hundredth and a tenth, and then a 1,000,000th. Okay, and so that's 10 to the minus 6. And you can also look at them as 10 to the third for kilo, 10 to the minus 1, 10 to the minus 2 if you're looking at it in scientific notation. Okay, nano, we don't use a whole lot in chemistry, but a nano is a billionth. Okay, so 10 to the minus 9. And these will be no matter what your base unit is. So you could have a kilogram or a kilometer. You still use those same prefixes. The other thing that we do in chemistry is we have to go in between temperature scales. For example, in the US, we tend to use the Fahrenheit scale. In all the rest of the world, they use Celsius. And then in science, we use Kelvin. And Kelvin and Celsius have the same difference between units. So in the freezing point of water is 0 degrees Celsius. The boiling point of water is 100 degrees Celsius. In Kelvin, it's 273 to freeze and 373 to boil, but notice it's a difference of 100 units. So 0 Kelvin is actually a negative 273 degrees C. Now the Fahrenheit scale doesn't really make a whole lot of sense from a round number standpoint. 32 degrees is freezing and 212 is boiling. Those are hard to remember, and their units are kind of funny. Also, there's a difference of 180 degrees in Fahrenheit between the freezing point of water and the boiling point of water. So because of that, we have to do some conversions of that. And so to do that, we have formulas. And so hopefully you had algebra and you know that you're going to plug numbers in and then do the math, and you should be able to come up with it. For example, if you want Kelvin and you know degrees C, then you just multiply the degrees C plus 273.15, and that's going to give you the Kelvin number. So in this example, 37.00 degrees C plus 273.15, and you're going to see the 0.15 in places. It's going to give you 310.15. Notice Kelvin does not have degree symbols because it is an absolute scale. Okay, and we're going to see a little bit more about that later. If you know degree C and you want to change that to Fahrenheit, you're going to multiply 1.8 times degree C, add 32 to that, and in the case of 40 degrees C, you're going to get a 104.0 Fahrenheit. And we're going to go through the steps of that in our example. So a sick child has a temperature of 40 degrees C. I guess that's the only thermometer you could find. 40 degrees C doesn't mean a lot to most Americans, okay, in the U.S. And so you need to figure out what is that temperature in Fahrenheit. And then if we're going to do something scientific with it, we'd need to know what that is in Kelvin. So I'll do the easy one first. If we're going to take degrees C to Kelvin, our formula is Kelvin equals degrees C plus 273.15, which is pretty darn easy. So K equals 40.00 degrees C plus 273.15 gives us 313.15 Kelvin. Notice that I put the K there because that's what my answer is in. And I am going to put a box around my answer. That way, if you've got a lot of numbers written all over a page, I know what you mean for the answer to be. Part B of this problem is that you want to convert degrees C to Fahrenheit. And so in this case, we know that degrees F equals 1.8 times degrees C plus 32. And so that's going to give us 1.8 times 40.00 plus 32. And that is going to give us 104.00 degrees F. So 40 degrees C is 313.15 Kelvin, or 104.00 degrees Fahrenheit. So all we do is plug those in. I call it plug and play. And so once you know a formula, you just have to plug the number in and solve. Make sure that you try with your calculator, okay? Because you want to make sure that you can get the same things that I'm getting when I do them, so that when you do it on the test, you'll be one with your calculator, okay? And make sure you use your calculator, the one you're going to use on tests. Then I wrote kind of all over it, but you also have a for practice, and this is how these will go. I'll give you an example, and I'll give you at least one practice problem. And if you have the workbook, the answers are in the back to all of these, even the practice. I also have them in Blackboard in the module units. Okay, so you'll see that underneath the in-class guided notes. So if you haven't found the guided notes, you need to stop and look for them, because that's what this is. These are those in-class guided notes that are going to kind of take you through this process, and you have room to write on them and work the problems out. And that's it for the first video.